Hi everyone, this is Sofiane Abbar from QCRI. I'm recording this video to present our paper to post or not to post, using online trends to predict popularity of offline stories. This is a joint work with my co-authors Carlos Castillo and Antonio Sanfilippo. So in terms of when it comes to predicting the popularity of online content, there's this very influential work by Szabo and Huberman in 2010, where they've shown that contents in different platforms such as YouTube and Dig have very specific characteristic, which is that early patterns of access to this content indicate the long-term popularity of the content itself. So in the figure, they've shown the distribution of popularity after 7 days obtained by this content in the x-axis as function of popularity after 30 days of the same content, shown here in the y-axis. And as you could see, there's a very strong correlation that can reach 0.9 in terms of percent correlation, but in the log scale. So this observation has been reproduced by so many scientists around the world and applied to different platforms and different types of content and used for predicting the popularity online. We have had in the past a very interesting collaboration with Al Jazeera Media Network, which is the largest media news platform in the Middle East, where we use the same kind of idea based on early measurement to predict the popularity of news articles published on Al Jazeera English website. So the idea was simple. The editors first post an article on the website. Then as soon as the article is posted, we start tracking different indicators like page views, number of tweets and retweets, number of likes and shares on Facebook. Using this time series, we could start training models to do predictions. So basically, we observe an article within 1 hour after its publication, and then we try to predict the popularity of the article in terms of number of page views for 3 days. Why 3 days? This is because the shelf life of articles was 3 days. Like 90% of articles get up to 90% of their visits within the first 3 days of publication. So this tool is integrated right now in the editorial process at Al Jazeera, and is very useful for the editors to figure out which articles are doing good and which ones are doing bad. However, the same editors came with a question. That is, can we predict the popularity of news story before it goes online? Popularity here again is measured in terms of page views. It can be generalized to other parameters like likes on Facebook, shares, retweets, and so on and so forth. So why is this question interesting? So it is interesting because in some events the editors reported that several journalists who write several stories about the same thing, and the editorial team has to figure out which story to push online. So if we can give them insights and hints using data, like data-driven insights, on which story will make better impact and will collect more page views, then this could be very useful for them to figure out which one to post and publish. The other use case that they mentioned to us is the real estate. So basically, the size of the front page of Al Jazeera English website is limited, and the number of articles they can push there is very limited. And sometimes they have two news stories and they don't know which one to put, right? Two stories related to two different events. So if they had a tool that could give them a sense of the popularity of articles in the future before they post them online, then this tool will be very relevant to them. And this is how it all started. So basically, in the related work, we observed the existence of two major families of work. So one is based on early measurement, which is very similar to what we've done in FAST. So basically, the content is posted first online, then we start collecting data about early access, building time series about page views, and so on and so forth, and then we do some sort of predictions and train models. The second family of work is what is called content-based methods, and here people try to look at some cues from the content itself. Like in the case of news stories, we look at keywords, named entities, the sentiment, stylish element of articles to try to figure out how popular they would be in the future. So in our case, we thought that, well, there are so many things that one could take into account in doing the prediction. So we thought of popularity of articles that are previously posted that are similar to the one at hand, right? So here we can look at the content similarity, but we could also look at the time decay, right? Are articles of that topic growing? Are they decaying? And so on and so forth. And then there's this aspect of interestingness of topics. Like when someone writes story, the story is usually about a topic. So how interesting is that topic for people right now, right? And here also we can think of two different perspectives. So from user perspective, the interestingness of topic can be measured as, the global volume of different page views of all articles belonging to that topic. And from an editorial perspective, the interestingness of a topic can be measured as the number of articles posted about that topic. So we try to leverage all these in a way that makes it possible to predict or to get close to the popularity that news story that is not published yet will get in the future. So now let me explain this through this example. So as you see to the right of the screen, we have a dot circle in red. Say that's the new article that we have at hand, and we wrote it today, right? Now this journalist writes this news story. What we could do is to go back in time, like we see yesterday, 2 days ago, 3 days ago, and so on and so forth. And for each day, we try to identify the nearest neighbor articles to the one we have at hand, which means the articles with the highest content similarity to the one that we have. So these articles will have different popularities, will have had accumulated different numbers of page views that are already represented in our system as time series. The second factor is the topic volume. So basically, if we have an article, we can try to guess the topic of the article, and we can also keep track of the volume or interestingness of the topic over time from different perspectives. As I just mentioned, from user perspective, that would be the total number of page views obtained by all articles belonging to the same topic. So here I took an example of topic that's growing over time, at least in the last 4 days. And then the third dimension that we could consider is the autocorrelation between the different time series to know whether an article or a topic that has been popular yesterday will be popular today, and so on and so forth. Now for the LDA, for the topic modeling, we used LDA. Basically, as you know, in LDA, we are supposed to provide the number of topics that we are interested in. And the problem here is that whatever number of topics you provide, you will get something that kind of make sense, right? So if the number of topics is small, we will end up having topics that are very general and broad, like sports and politics. However, if the number of topics, K, let's call it K, is large, so LDA will generate specific topics that are narrow in nature, which could be like NFL or soccer for sport, and so on and so forth. And what we want ideally is to have some sort of mixture between them, between broad topics and narrow topics, based on the number of articles that the news media post on their website. And here I'm just giving some examples of narrow and general and broad topics. So one thing that we've done in this work is to try to come up with a way to figure out what would be the best number of topics to have here. So in order to do that, what we've done is that we run LDA with different number of topics ranging from 1 to 100, and then for each run, we kind of label every single article with its dominant topic. And once we have this association and mapping between articles and topics, we train a naive byte-based classifier to learn the labeling, and then we apply it on a test set that was not used in the training, and then we estimate the accuracy of the classifier in terms of precision, recall, and F1 score, and we track the F1 score for different numbers of topics. So here the idea is that the best number of topics should be the one that could allow a classifier to better label articles, right? And in our experiment we found that 20 was a very decent and a clear win among other values, which also kind of makes sense given the nature of the news topics that are covered by Al Jazeera network. So now for the forecasting, we use different techniques. So we tried linear regression and SVR, and let me tell you here, so basically we reviewed the literature, and in many cases we've seen that simple models like linear regression achieve much better accuracies than very complex LSTM kind of based models for many reasons. This is why we decided to go with linear regression, and then we just tried it, contrasted it with an SVR kind of regression. And in terms of features, we looked at different things. So we looked at the popularity of nearest neighbors, like similar articles that have been posted in the past. We tried then next to account for the topic of the article itself, and we looked at the time series of those topics and so on and so forth. And finally, we tried also to predict for the predicted topic volume, which means that if we have the time series of topics, right, we could first predict the volume of the topic in the future and then use that information to strengthen our prediction model for the popularity of single articles. So for some results here, so for the nearest neighbor and topics, we have three models: NN nearest neighbor, and then topic only, and then NN plus topics. And we've seen that NN plus topics achieves better MAPE score. So MAPE is for median average absolute percentage error, and the lowest the better, of course. So that was like very interesting. One of the most interesting observations also to be made here is that topics are much more important in revealing the popularity of articles than nearest neighbors, right? So yeah, that was kind of surprising to us. So next, we try to incorporate the predicted popularity of topics and compared it with the best model we had before, which is NN plus T. So now we have NN plus T plus TP, where TP is the predicted topic popularity. And what we found is, by doing that, we kind of slightly improved, but that improvement is very limited compared to the nearest neighbors plus topic model. And then we wanted also to figure out or to compare our methodology that's completely based on online trends plus the content of articles and compare it to the early based measurement kind of techniques, what we had in FAST, right? So here we have different models where we actually try to account for the access patterns of different articles within the 5 first minutes of publication, 1 hour and 6 hours. And to our surprise, we found that even when you observe an article for only 5 minutes, you can make much better predictions about its popularity in the future than accounting for all what you have in your historical data, about similar articles, about topic trends, and so on and so forth. Which means that online real data about articles that are observed at early stage really matter in predicting the popularity of articles. So that was like our main finding in this paper. Now when we presented this to the editorial team with which we were working, actually they said, okay, it's fine that this is the case, However, in their case or in their scenario, what happens is in many cases they can't afford to post an article and then remove it, right? You cannot post an article for 5 minutes just to see whether the article will be popular in the future or not. In which case, having approximate estimation about the popularity is more than enough. Thank you very much. For questions, please feel free to email me at sabbar@qf.org.qa.